Hi everyone, welcome to the Becoming a ROS Developer channel here at the Construct. My name is Rodrigo, and today we have a presentation, a project presentation from our student Andre, who worked on the ROS Basics course in Python, and he developed a project to control a Turtlebot, both in the real robot and in a simulation, implementing the main components for learning the ROS basics, which would be subscribing and publishing to topics, the usage of service and action servers. So, hi Andre, how are you doing?
Hi, Rodrigo. I'm good. And you?
I'm good. I'm good. Excited to see your project. And just to let you know, you have around 15, 20 minutes to show it. And you can share your screen and just talk about how you did each section. So whenever you're ready, you can go ahead and start, Andre.
Perfect. Thank you. I'm just as excited to show it.
Great.
So I'm just going to share my screen
Okay.
over here. Can you see it?
Yes, we can see it.
Okay, so for anyone watching, in the bottom right, we have the real robot already running in the construct in Barcelona, Spain. And now I'm just going to show you just a big picture of the project, and then I'm going to detail it a little bit.
Okay, great.
So, well, in the project we have the package that I created. It's this Turtlebot 3 underline move, and inside it we have the action folder with the action message description, the launch folder with the main launch, launching all the necessary files and nodes, and then the script folders with my Python scripts doing the things that the robot should do. And then the other files that Cat can make or Cat can build creates it, and that's it. So let's just begin by the launch file. So here in the launch file, we are always launching files from the Turtlebot 3 underline move package. And the first one is the service server, then the action server, and then the sub and publisher. That it's kind of my main file that runs all the clients and some other features from the robot. So let's go to this one first. Okay, so here we are importing all the necessary files. So ROS.py, since I'm working in Python and using ROS inside it. Then we have the twist messages to make the robot move, the laser scan to get readings from the laser, the move in square and move in square requests, which are my service messages. Then we have the odometry messages from my actions. That's why we have 4 different kinds, from feedback, result, action, and go. Then we have my action client, which I just separated in a different Python file, and my service client, which I separated as well. So when we initialize this file from the launch, we initialize this node, topic sub pub node. Then we call the action client, which is the first thing that you should do in this project. And after that, we call the service client. So I'm going to the action client right now, just to show it. This is my action client. What it basically does is it starts to record the odometry of the robot. You can see that I tried a lot of different stuff here, and actually the final result is a lot simpler than that. So this file just starts recording the odometry for that. It's going to run throughout the whole project, throughout the robot execution. So I'm going to enter in details after that. So getting back to subpub, after this one, we just call the service. And the service is that task that the robot has to move in a square shape inside this area right here.
Mm-hmm.
So I'm just defining this function that I called in the main file. Um, I provide the service name, then call the service server. And let me see, I think I can show the service server right now. This is my service server, which is executed when I call it. So I just create this class, real robot, following the instructions from this project. I think it's easier if you work with classes.
Yeah.
And okay, so I defined some procedures for this class, which is just moving, stopping, moving straight for 15 centimeters, turning 90 degrees, some laser scanning as well. And then here is the moving square itself doing its job. And this is when you call the service server. So it just prints to the user that it's been called and executes all that beautiful stuff. So getting back to I'm going to detail it after this big picture tour. And finally, when we finish the service call, and we need to remember that the service, it needs to be finished before doing any other stuff. We just get into this kind of infinite loop of the robot, where it just keeps reading, seeing, detecting if it has any obstacle in front of it, and it just keeps moving to, and when it finds an object, it stops. I think we can like improve this project, like turning 180 degrees or any other stuff like this, turning a little bit and getting backwards, just to keep the robot moving
Right.
continuously. But it's not this implementation right now. And
So let me ask you,
one,
can I ask you something really
yeah.
quick? So when it sees that obstacle, what happens to the calls for the service server and the action server? Do they,
Yes.
are they marked as completed, or what happens in your program?
Okay. Let me just show you the action first.
Yeah.
Okay, so here we are just connecting to the action server. This is the feedback. It just keeps printing the total meters moved, the odometry.
Yeah.
Action server. And then on the action server that I didn't show you yet, let me show you.
Okay, yeah, I'm seeing you're accessing the odometry position.
Yeah.
To record it.
So I just create this variable, which is obstacle false. And as long as we don't find any obstacle, it keeps repeating this while loop. I don't find it really beautiful creating a while loop with while true over here, but that's what I came to be.
Right. I mean, if it works, it works. So when it's false, that means there's no obstacle, and when it's true, that means that an obstacle was seen.
Exactly.
So you start, or what's happening inside of that while loop? It's
okay. So we first check if the action has been preempted, and if not, we just continue, and we append the last odometry reading to the result variable here of this class. We create this this simple math just to calculate the odometry, how far it has gone.
Mm-hmm.
In the X, Y, and Z position. Of course, it basically never moves in the Z position. Just for,
Yeah, if
but
it
I
was a
just
drone, it
put it
would.
here. Yeah, if it was a drone, it would move. And I just create the feedback, which is the current total meters moved.
Mm-hmm.
And that's just basically the summation of all of these movements in the 3 axes.
Okay.
Then I publish this feedback, which the action client gets and prints for the user, and sleep for in a 1 hertz frequency or for like 1 second. Then over here, if we exit the while true loop, it means that the action has been preempted. Self obstacle is now true, and then we just print that the robot stopped. So the question is, how do we preempt the action, right? So that's I think this was the hardest part of the project, at least for me, because I was just trying to understand how I could preempt the action from another file. But let me just find it over here, I think. Maybe not. Okay, no. Return client. Let me just check it once again where it was. Okay, yeah, I think it's over here. Okay, so here, when I call the action client, I actually makes it into this variable action client itself. So here in the action client file, you can see that I just return the whole client and assign it to this action client variable over here. So since inside the laser callback here, I already make those readings about the obstacle over here, I can't just preempt the go over here about the odometry reading. So that's when we set the obstacle to true.
Right. Okay.
And okay, so this was just to show you the obstacle detection inside the action client. Then we have, of course, the obstacle detection over here in the main file, which is this whole function. So we are just getting those readings from the laser scan. I think it's better if we just make the middle laser scan not exactly one reading of the sensor and just a small range.
Yeah, that's a good idea.
Yeah, that's why I selected a like window here
And
of
how
10 readings.
10 readings. Okay, so that's like
Yeah.
360. That's like a couple of degrees of range.
Yeah. So, and then I just to check, of course, over here if it's in less than 20 centimeters.
Any of those readings or like the range? I'm sorry to interrupt.
Any of the readings. So
Okay.
that's why I use the minimum function over here.
Right.
So I just get if there's anything inside this range less than 20 centimeters, then it's going to stop the robot.
Right.
And then I just make sure that I unregister from those laser scans just to end the project, the execution of the robot. And then just to finish answering your question, we have the service client over here. So, okay, this is the service client, connecting to the service client and just making a request that is passed through to the service server, which is this file. And then inside the service server, I really don't like the solution as well, but I don't know if I could make anything different. Probably I could. So I'm just reading those laser scans. I'm subscribing to the laser scan again inside the service server. So this is how I can detect the obstacles. Just as in the main file, I just repeat the code over here and detect any obstacle inside the service execution.
Right. So your server is subscribed to the scan as well. Okay. Yeah.
Yeah. I really looked into the deconstruction forum and Stack Exchange and a lot of other websites to see, but I couldn't find any other solution by myself. So let me just show you. Yeah, so this is the laser scan loop that we are making. And that's just exactly the same thing as in the main file. So I create that little range of sensor readings. I check if it's more than 20 centimeters. And if it's not, if it's less than 20 centimeters, then I just set this variable obstacle detect to true. And inside any movement of the robot, before making that move, it detects if this obstacle detect variable is set to true or false. And then it just acts accordingly.
Great.
And I think that that's how I detect the obstacle in any of those circumstances. Okay, so maybe I could show the robot right now. I think it just disconnected. Is my time?
Oh, yeah, that's probably, yes, that's probably, yeah, it got disconnected. So we don't lose that much time. Why don't you show us in the simulation?
Okay. So let me just open Gazebo.
So you should disconnect first if you're connected to the robot. Oh, I think it kicked you out automatically.
Yeah, it clicked me out.
Okay, then let's just see it in the simulation.
Okay, so let me just get Gazebo right here. Okay, so right now I'm just launching the Gazebo simulation launch file about this turtle robot in the exactly the same environment as the real one. I promise it works in the real one.
No, yeah, that was.
Okay.
I should have given you more time, but that's okay. Well, you can show us here. The only difference is that the ranges in the laser scan are.
Yeah, I noticed that.
Are doubled, but I saw in your program you're doing relatively like getting the exactly. So it wouldn't matter how many.
Yeah. So
unless it was.
I'm getting the length of that array. So I'm always getting the middle of that array. Even if it has a more precise sensor with more readings. Okay, so now I'm just going to launch my file. And we hope that it works.
So then I can
see here
the server, both servers and your main. Okay.
Yeah. And okay, so the robot is moving right here. The odometry is recording. I don't know why, but sometimes it doesn't show the bottom of my shell over here.
Yes,
So you can see that.
that's a display issue, and you
Okay.
could open a new shell, for example. But yeah, that happens sometimes. But
Yeah. You can see that it's recording the odometry
uh-huh.
and it's moving.
Okay, and this is doing the square movement.
Yeah,
When
this is the
does
service call.
when does it start this square movement? Does it right away, or it goes first to look for a wall?
It looks for a wall. We can do that again in the end of the
Yeah, yeah.
execution. I can run it once again. Okay, so now it's not in the service anymore. It's just in the main file,
Oh, okay.
knowing that.
So the service call is being completed, and it's just
Yeah.
gonna keep going then.
Yeah, here you can see complete, true. And now it should stop. Okay, so now it stops
And it returns. Okay.
the odometry, all of the odometry. It displays to the user obstacle detected. That's the distance of the obstacle.
Oh,
You can see
nice.
it's less than 20 centimeters. Then it cancel the action go, returns that result. And let me just make some enters over here. Just, yeah, and that's it. Robot stopped.
Great. So basically, the action never returns a success, let's say, because it's always going to run into an obstacle eventually, right?
Yes,
Okay.
yes, exactly. So, and that's another thing that it was hard for me
Yes,
because
yes.
it wasn't going to be a success. So I just had to like print the result or anything
Right.
related to that. Okay, so now let me just create a new shell over here. I can launch it once again, just to show you that it detects the obstacle right away.
So it would be the first thing, yeah. So for that action server, you could do that a bunch of different ways with like flags or things like that. But
Okay.
yeah, because sometimes you do need that action to be returned as true, you know? So, because
Okay.
this way the system wouldn't know, right? That the whole process is being completed. But yeah, this is, I mean, it does what it's supposed to do.
Okay, so you can see here that it starts the nodes, it calls the files, waiting for the action server. Okay, subscribed to Odom, subscribed to CMDVL.
And since there's an obstacle, it just, yeah, okay.
So it obstacle when service called, so right at the beginning. And it just returns this list of odometries because that's all
The first,
that it could read.
yeah, okay.
Yeah.
Okay. So
That's it.
you need to make sure then in this setup that there is no obstacle in front.
Yes, yes.
So let me ask you, is there a way you can think of in which the whole process would get started, even let's say with the first obstacle? So if you started in this position, what could be a way to ensure that the robot does turn around or something and tries to do it?
Yeah, so over here in the service server, where in the callback of it, if there is a service, if there is an obstacle, so instead of just stopping the robot and like returning that there is an obstacle, I could just make a 180 degrees or anything like this, and it would start the robot.
Right. Yeah. That was what I wanted to look at. If you had like a scenario. Okay. Yeah. So then on those things, we cover the subscription, the service server, and the action server. And the service server in this moment, it returns the success.
The service server, let me.
So it should say obstacle stopped, and it says complete false. Does that mean, is that related to the service server in your output terminal? Okay. So it says I couldn't complete the service call.
Yes, exactly. I think that's the right result because you called the robot to do a specific task and it didn't.
Can't do it. Yeah. All right. Well, good job, Andre. I mean, I think we covered everything. Is there anything else you want to point out that?
No, I think I can improve a lot of stuff, and probably I will revisit this project after learning more stuff. I started this course because I'm about to start a master's degree in autonomous driving.
Oh, nice.
And yeah, I need to learn ROS and I need to learn sensor fusion, Kalman filters. And
yes.
I see that you guys have all of this, and I just need to keep studying. So definitely, I will improve it.
This is what we do. Well, let me tell you. Do you mind stop sharing your screen so we can see each other?
Sure. Let me just check it. Okay, stop share. Yep.
Let me make sure. Okay. Yeah. So what I was saying is that, there's definitely room for improvement, especially in a project like this, because we don't ask for the full proof of the system, but this is just a way to sort of get the basics going, and then you can think on top of that. Like you were saying, you can improve on it. Because, for example, when you're working with a robot and you want that service to be called and that action to return completed, you can start thinking about what modifications you need to do in order for it to just be. I mean, the first step is like, okay, there's something in the way. I don't want to keep going because I'll run into it. And then the second part is sort of a not corrective, but a way to go around it. And that's why I was asking you about the service server and all that. But if you're taking a master's in autonomous driving, this is a great place to start. And we actually have courses in localization and things that touch on Kalman filters and things and GPS localization that deals with autonomous cars. Is there something specific, a project that you're working on, or is this just something that you wanna do?
No, it's actually specific. It's a truck that it's currently in SAE level 2 of autonomous driving, and the guys in the team are trying to get it to level 3. So so it's of course it's a big team, and my part is about sensor fusion.
Okay, and, so fusing the odometry, the GPS,
odometry, point cloud of lidar, radar. And
you can even add visual odometry. From a camera, there's if you're doing it in ROS 1, there's a package called RTAB map. It's called that. It takes in the input from a camera, and it does visual odometry that you can include into that Kalman filter to improve it. Because I know sometimes you have in that project there's our GPS sensors, right? Yeah, because sometimes you lose that that signal, so that's a way to improve that localization is by adding. But that's really interesting.
That's redundancy, right?
Yeah. But anyways, Andre, thank you so much for your presentation. It's a bummer that we ran out of time there for the real robot, but we got the main idea. And this is for everyone out here that wants to do the same. You can come to the construct and take our course. And for that final step in some of the courses, you can take this project where you present your knowledge. And I think this is a very good step to, first of all, show that you know what you're doing and that you took something away from the course. And yeah, so this could be you guys. And I just want to thank you again, Andre, for a great job.
Okay,
And
I appreciate it. Thank you.
hopefully
And thanks for the construct team. Thank you.
Yeah, thank you. And I hope we'll see you around still. So thank you very
Yep,
much, you guys.
definitely.
And we'll see you again next time. All right. Bye-bye.
Bye-bye.
Okay, we're good. Nice.